Welcome to another episode of Continuous Improvement. I'm your host, Victor, and today we are diving into the world of networking subnets. We'll be demystifying the process of calculating the number of available IP addresses. So, whether you're a networking newbie or an experienced professional, stick around because we've got you covered. Before we get into the nitty-gritty of subnets, let's start with the basics. In computer networking, a subnet, or subnetwork, is a way to divide an IP network into smaller, more manageable segments. This subdivision serves multiple purposes like enhancing network efficiency, improving security, and organizing IP address allocation. IP addresses are unique numerical labels assigned to each device connected to a computer network. They consist of a network portion and a host portion, and the subnet mask helps us distinguish between the two. For example, let's consider the IP address 192.168.1.100 with a subnet mask of 255.255.255.0. In this case, the first three octets, 192.168.1, represent the network portion, while the last octet, 100, represents the host portion. The subnet mask tells us that the first 24 bits are allocated for the network and the remaining 8 bits are available for host addressing within that network. Now, let's get into the exciting part, calculating the number of available IP addresses in a subnet. It's like solving a puzzle. Here's how you can do it. First, take the subnet mask and convert it to binary form. For example, the subnet mask 255.255.255.0 becomes 11111111111111.11111111.0000000. Next, count the number of zeros in the binary representation. In our example, there are 8 zeros, indicating 8 bits available for host addressing. Now, here's where the magic happens. Use the formula 2 to the power of n, 2 to calculate the number of possible host addresses. Then represents the number of host bits. Subtracting 2 accounts for the network and broadcast addresses, which cannot be assigned to hosts. In our example, 2 to the power of 8, 2 equals 256 to 2, which gives us 254 possible host addresses. It's important to note that as the subnet size increases, the number of available IP addresses decreases. Subnets with smaller subnet masks allocate more bits for host addressing, resulting in fewer available hosts. For those who love visuals, we have a comprehensive chart listing various subnet sizes, their subnet masks, and the number of IP addresses available, both total and usable. You can find the chart in the transcript of this episode on our website. Subnetting is not just a theoretical concept. It has practical applications in the real world. In a corporate environment, organizations often allocate different subnets for different departments or floors of a building. This segmentation enhances network security and allows for efficient allocation of IP addresses. For network administrators and engineers, subnetting is a crucial skill. It enables them to optimize network performance, manage IP address allocation, and implement effective security measures. And that's a wrap on subnets and calculating the number of available IP addresses. We hope this episode has empowered you to tackle these concepts with confidence. Remember, understanding subnets is fundamental to designing, configuring, and managing networks efficiently. If you found this episode helpful, don't forget to share it with your colleagues and friends in the networking world. And as always, feel free to reach out to us with any questions or suggestions for future episodes. Until next time, keep improving and stay connected.